myAP practice problems packet. So I got the notes are already on there. So hopefully those are helpful, but sometimes it's certainly useful to go through and talk through each one. So I'm just going to pull out the notes that I did and talk through what I did. So horizontal line at y equals 2. Well, if there's a horizontal line, or as an asymptote, if there's a horizontal asymptote, that means that either the limit as x goes to infinity has to equal 2, or, because that would be like it's coming this way and leveling off, or as x goes to negative infinity, you've got to level off at 2. So there's two possibilities. It could be all the way over here, you end up at a y value of 2, or approaching a y value of 2, or it could be all the way over here, you are approaching a y value of 2. So your y value definitely needs to be 2. And this is the one you're talking about. So limits at infinity, this would be x is approaching infinity, like way over here. You're leveling off to a y value of 2 because we've got a horizontal asymptote at y equals 2. Second one, if I want the limit to be 0, so as x approaches infinity, you're looking for 3 situations. Where's the higher power? Top, bottom, or tied? So in this case, it's on the bottom. The answer is 0, so we want the higher power to be on the bottom, because that will give us a horizontal asymptote at y equals 0. Well, here the higher power is on the bottom. 99 is bigger than, this is really like x to the first. Here the higher power is on top, because if I plug in infinity, I'll have a power of infinity up there. And again, this isn't really a power, that's just like x to the first. And the LN's a little bit goofy. But really, you're just looking for the highest power. So then again, down here, infinity is bigger than 99. So that is 1 of 3. Third one, part A, you don't know yet, so that won't be on there. That's about a derivative. So they're saying if the limit exists, which of the following must be true? So this one you don't know, it's not true. And then if the limit exists, it's saying, does it have to be continuous? Well, no, because even in this situation where it's not, there's a limit there. Does it have to be defined? No. Even in this situation where there's no closed dot, there's still a limit there. Does the y value equal the limit? No, but there's still a limit. So none of those things have to be true for there to be a limit. Those are the things that have to be true to be continuous. All right, fourth one. Again, you don't know differentiable yet, so this question gets a little bit goofy. But just because the limit equals 3 doesn't mean it's continuous. There can be a limit even if it's not continuous. And just because the limit is 7 doesn't mean that the y value is 7. There might not be a y value, or there could be a y value like down there. And this is not true, but you don't know it yet. And you're not responsible to know it yet. Number 5. So they wanted to know when it was continuous. Well, if it's continuous, the two roads have to meet. So I set them equal to each other. X squared minus 3x plus 9, and then kx plus 1. And then I know x is 2, and I'm getting that because 2 is where the roads potentially come together. That's the x value that we're interested in. So I plug in 2 for x, and then I solve for k. Before, when I printed this, I got this weird text up here. I don't know, I guess instead of a photo, but so this is the question that I wrote. If f of x is equal to x squared minus 4 over x plus 2, and if it's everywhere continuous, find f of negative 2. So typically to find f of negative 2, we're going to plug in negative 2. The problem is I'll get 0 over 0. So I'm stuck. So I can't find the actual y value. But I can find the limit. And if you remember, this is why I spell limit like this sometimes, because limits are y values. So if I find the limit as x approaches negative 2, I can factor the top, and then I can plug negative 2 into what's remaining. And now I can get my answer of negative 4. Number 7, so if it's continuous at x equals 3, what is the value of k? So this is like number 5. These two have to be equal to each other if it's going to be continuous. So this is me setting them equal to each other. This says 6x plus k, and I know x is 3, so I plug 3 into those two spots. This just says plus k, and then I'm working out the algebra. Number 8, this is a great question. I really like this one. So they want you to find a and b. You just really have to know your stuff, and you're going back and forth between a graph and an equation. Really good problem. If you understand this problem, you should feel really good. So this here means I have a horizontal asymptote at y equals 3. If I have an asymptote at y equals 3, that means if I have an asymptote at 0, the highest power is on the bottom. If I have an asymptote anywhere else, the two highest powers were tied. So I have this situation here, the two highest powers are tied. And if and when they're tied, I look at the coefficients. Well, a over 1 has to be 3. Because if this is 3x squared on top and x squared on the bottom, then 3 is what I'm left with. So this a has to be a 3. Now, the next thing I know is I got a vertical asymptote here at x equals 2. Vertical asymptote means the bottom equals 0. So if I plug 2 in and solve that for b, that tells me that the bottom is negative 4. Number 9. So again, you don't know differentiable. This one's not. I'm going to really do my best to not put these on the test, but sometimes it's just tricky. But anyways, so, okay. I want to know, this is a giant road with a hole in it. This is a bridge at 1. I want to know if this bridge fits into this spot or not. So I got to find the limit here, which is the y value. And see if I get 1. If I get 1, then this bridge is right in that slot. If I don't, then these are in different spots. And then that changes the game a little bit. So I can't plug in 2 right now. I'll get 0 over 0. So you go x plus 2, x minus 2. Bottom is x minus 2. Cancel them out. If I plug in 2, I get 4. So these two roads meet at a y value of 4. The bridge is down there. So it does have a limit. The limit will be 4. But it's not continuous because the bridge is not in the right spot. And it's not differentiable, but you do not have to know why. Number 10, where is this not continuous? Well, discontinuities happen when the bottom equals 0. So if I set this part equal to 0, I'll get x equals 2. If I set this equal to 0, I'll get x equals negative 1. And those are my two discontinuities. Number 11, what's the domain? Domain is the set of values that can be plugged in. So I can't plug in a negative, or I can't get a negative number up here. I can't take the square root of a negative. So the x squared minus 4 has to be greater than 0, which means x squared has to be greater than or equal to 4. And keep in mind that the squaring makes it positive. So even if I put like negative 3, the absolute value of negative 3 squared would be 9. So you got to look at the absolute value being bigger than 2, because then when you square it, it'll be 4 or bigger. And x cannot be 3, because if I put 3 in, the bottom becomes 0. Number 12, again, I get this weird graph text issue, but this is the question, and they're saying, what is the limit as x approaches infinity? As soon as I see that, I'm looking for the higher power. The higher power boils it down to this, because none of this stuff matters, because it's not the higher power, and then you cross out these and look at the coefficients, and you'll be left with negative 1/4. 13. So y equals 5 is a horizontal asymptote to which graph? And then they give you, it's these 5 choices. That image weird thing happened again. But if I have a horizontal asymptote, what that means is the highest powers were tied, and the coefficients simplified to be 5. So if I look at option E, I got a squared and a squared, and then 20 divided by 4 is 5. And that's where that comes from. 14. Which of the following statements are true? As I approach 2 from the left, it's negative 1. That's equal to f of 2. Well, that's also negative 1, so that one is true. As I approach 6 from the left, that gives me negative 1. 6 from the right, also negative 1. Those two are equal. Does the limit as x approaches 6 equal f of 6? No. The limit is up here at negative 1. The value is down there. So those are, 3 is not true. 1 and 2 are the ones that are true. So let's see. 15. Horizontal asymptote. So again, we're going to look at the higher powers. But you have to simplify before you look at them. So I'm not even going to really worry about the foiling the whole thing. I only care about the biggest powers. So, I mean, could I foil these and get a trinomial? Sure. But x times 2x is 2x squared, and that's where the biggest power is going to come from, so I don't really care about the rest. And the same on the bottom. I could expand on that, but the x squared is going to be the biggest power, and that's all I care about. And then the highest powers are tied. You're left with 2. So that's y equals 2. 16, similar idea. You simplify and then compare. Horizontal asymptotes, it's the same thing as limit as approaches infinity, and you're looking for higher powers. Hopefully you're picking up on this theme. But you simplify first, and then we do have to worry about the sign. So if I simplify, this becomes 2x over x, because the square root of x squared is x. And if those powers are tied, so then I get 2. But that square root kind of messes with things. Now I've got to check both directions, positive and negative infinity. So I imagine plugging in a gigantic positive number. Let's say I plug in 1,000. The top would be positive, the bottom would be positive, so that would give me a positive 2. What if I plug in negative 1,000? Well, now the top would be negative. The bottom would still be positive because you square it, which turns it positive, and then you square root it. So negative divided by positive, so if I go with the negative infinity, I get negative 2. So you've got to check both of those, and those are your 2 answers. Usually that doesn't come up. You don't have to really worry about it. I just noticed on this one, because they got the 2 and negative 2, it's like, okay, I probably need to check both. 17. So it's a little tricky. I'm going to look at the higher power on the inside and worry about, okay, if I plug a gigantic number into that, because we're looking at horizontal asymptotes, so I'm plugging in, my air quotes, plugging in a huge number, plugging in infinity. So if I plug infinity into that, it comes out to 0 because the higher power is on the bottom. Or imagine like the top is infinity and the bottom is infinity squared. And, a number divided by a number much bigger is basically 0. So then I get sine of 0. Well, is sine of 0 0? Yeah. Is sine of 0 1? No. Vertical asymptote, if it's a vertical asymptote, we're going up forever or down forever. So the y value comes out to be plus or minus infinity. X value plus or minus infinity is a horizontal asymptote. Y value plus or minus infinity is a vertical asymptote. And the issue here is you can't have a y value of infinity because you're taking the sine of something. The biggest sine can possibly be is 1. So 1 is the only true one there. 18. Horizontal asymptote again, so this is the equation. Again, I'm going to expand it, simplify it, but I'm not worried about the whole thing. I know that to get the highest power, I'm going to multiply those two together, which gives me negative 12x squared. And then if I take the 2x and square it, I'll get 4x squared, and the rest of it is not going to be the highest power anyway, so it doesn't matter. Those cancel, divide, negative 3. 19. Which of the following equations has y equals 1 as an asymptote? All right, if it's a horizontal asymptote, the highest powers have to be tied. The coefficients have to come out to 1 because they want the horizontal asymptote to be 1. Not even a fraction. Not even a fraction. Highest power on top. This is actually the highest power on the bottom because it'd be 1 over e to the x. So this limit is 0. This one is positive or negative infinity. And this one is 1 because the highest powers are tied, and if you take those coefficients, 1 divided by 1 gives 1. Number 20. This is a key word here, continuous. Relative max at negative 1, 4. And what that means is you got like the top of a hill. Relative min at 3, negative 2, so you got kind of the bottom of a hill. Which of the following must be true? F of negative 1 equals 0. So it does not have to go through this point. Does it have to have a horizontal asymptote? No. Point of inflection, you don't know what it is yet, but that one's not true either. And then horizontal tangent line at x equals 3, we don't know that. Graph intersects both axes. So you can just kind of draw it, even. It's continuous. So you're not going to pick up your pen, and if I draw, like there's no way to get from here to here, there to there, without crossing through both axes. That's the intermediate value theorem. 21. So, first of all, polynomials are continuous. Polynomials like x squared, x cubed, x to the 4th, it's just like wiggly stuff. Again, relative max, here negative 2, 4, relative min at 1, 1. So we got a max, a min, and then a max up here. How many zeros does it have? So how many times does it cross the x-axis? Well, you got this, and that means it came from there. We go down to this relative min, but then we go, that's a min, so we don't go lower until we get to this max and then go back down. So there's actually only going to be 2 times that it hits the x-axis, there and there. 22, more intermediate value theorem stuff. If f of x equals a half is going to have 2 solutions, then, okay. So if I'm just going to try the answer. If I put 0 there, well then 0, 1, 1, 0, 2, 2. I need 2 solutions for the line y equals 1 half. 1 there and 1 there. You could think about it another way. 1 half is between 0 and 1. 1 half is also between 0 and 2. 2 answers. Any of these other numbers that I put here, I wouldn't get 2 answers. Number 23, I got this 0, 1 and 1, 0. And this is it. I don't really like this question very much, to be honest, but so I know these 2 points. What this tells you, so we're looking for which of the following is not necessarily true. What this tells you is that there is a point where the y value is greater than or equal to every other y value. That just means there's a peak. There's a spot that's the biggest or tied for the biggest. If A and B are the same, if A and B are both 3, then plugging in A and B should get you the same y value. That's true because it's continuous. There is a number in between there such that the y value is a half. So if I draw a line, I'm going to cross through that y value of half. So yeah. There's a line between there where g of x equals 3 halves. Well, 3 halves is up here. So there is not necessarily going to be an intersection of that line. This might go up and get it and come back down, but it also might just not. 24, look at the higher power. Again, I'm just multiplying the higher powers together. They're tied. Divide, I'll get -2. 25, again, just simplifying the higher powers. None of that stuff matters. 3x to the third, they're tied. Divide, you get 3. 26. Simplify the top part, you get 3x squared. On the bottom, it's 4x squared. Well, the highest powers are tied. You get 3/4. Number 27. None of that stuff matters. Highest powers are tied. Cross them out. 1/4. 28. I'm going to go through the wrong answer. There's just too much nonsense here to spend too much time on. But C is wrong. C says the limit as x approaches 4 doesn't exist. But the limit as x approaches 4, wait a minute, it does. The switch to the following is false. This says that the limit as x approaches 4 does exist, but it doesn't. Because from this side, you get to one y value, and then from this side, you get to a different y value. The roads don't come together, so there is no limits. 29. Find the limit as x approaches 2. So I need to plug 2 into this fella and 2 into this fella and see if those roads come together. Plugging in up here gives me ln of 2. Plugging in down here gives me 4 times ln of 2. So no, they're not going to be the same because one's multiplied by 4 and one's not. 30 is a pretty standard factor and cancel. I don't think that was too bad. 31, if the limit is infinite, that means the highest power was on top. Again, if they're tied, there's going to be a horizontal asymptote at the coefficient, and the higher power on the bottom means horizontal asymptote at y equals 0. In this case, you just need the highest power on top, so I chose the one that has the highest power on top. 32, this is good to review one of those absolute value ones. So they want the limit as x approaches 3 for the left. So the first thing I have to figure out is if I plug in a number just to the left of 3, does that result in me having to change the sign of what's in here or not? So if I plug in like 2.9, 2.9 minus 3 is -0.1. And when I take the absolute value, I do flip the signs. So in the case when we're just to the left of 3, it's really -1 times x minus 3 because I had to multiply what I got when I plugged in 2.9 or 2.99 by a negative number to flip it to positive. So then that's what goes over there. Actually, this is the better version of it because when I wrote this, I was like, oh, I have to factor out a -1, and I end up with x minus 3, which is kind of where I was there. And then these cancel, and you get -1. 33. If it's going to be continuous, so when you get this not equal, again, that's a road and a bridge. And our job is to see if they're in the right spot. And in this case, they're actually saying what would put them in the right spot. So I'm going to set them equal, and then solve. So when I set them equal, I notice that these canceled. I just got 2x plus 1 equals k. Plug in 2 for k, and you get 5. 34, not equal. So again, we got a road and bridge, and we want to put the bridge in the right spot. So where would this y value have to be to fill in that bridge? Again, I set them equal. And then I noticed the top factors, and it actually has a common factor. So then I crossed those out. I multiplied both sides by b, and I got x minus 5 equals b squared. Well, then I plugged in 2, and I got 2 minus 5 equals b squared. So I got b squared equals -3. And when you go take the square root of that, it doesn't work. So there is no such value. And then 35, if there's a horizontal asymptote at y equals 2, these two powers are tied. So that has to be a 2 since that's a 1. So 2 over 1 gives us that coefficient. And then the bottom has to equal 0 if there's a vertical asymptote. So if I put a 3 there, oh wait, that's -3. If I put a -3 there, C has to be 3 to make that 0, and then 2 plus 3 is 5. Peace.